Alright, hello and welcome to Kerbal Space Program 1.8.1? Yes, it is 1.8.1.26904. Yeah, I noticed a lot of the modders are updating. Doing a lot of cool modder stuff. If you look, I've utilized my bigger rocket, more gas tanks, and I'm going to try to get this to get me close to about 60 or 70,000 meters. That's the whole idea. And I'm actually going to be dumb enough to take a scientist with me. Excuse me. Now what that does for me is that'll allow me to extract the information and reset this module. Use it multiple times. So let's just start by going out, taking this ship. I didn't check the staging. I'll need to look at it real quick. And we are going to go. Looks okay. Staging. Let's go for a observe material bay. Alright. Looks like we may have only done this and we can only recover 1.6, but we will keep that. And we'll go on an EVA and we're going to collect the data, remove data, and then we're going to restore. Now we can get right back to business. And we can do that as many times as we want, as many biomes as we want, if we have a scientist. Anyway, one problem is he doesn't quite have the absolute control at this stage in the game until we develop better technology of finite pilot control, so everything's a little bit loosey-goosey. And we just basically aren't going to have any vector locks. Everything's going to be fluid and manual and have to be monitored, and our ship needs to be balanced and stable. Alright, so let's go ahead and launch. I need to fix it. I don't like that how the light always comes on every time I launch. Alright, so what I'm going to do here is to watch my fuel consumption, do a halfway check my G-force, check my thrust. I'm about 500, 700 vertical speed, 1000 vertical speed. This is incredible. G-force almost into G-max. It's bad. Alright, I'm about to run out of fuel at 68,000. Giving it gas, putting it on 72, and then I'm just going to trickle it like this. I'm losing speed. I'm going to try to match my speed so it stops going down. Just put it right there where I see that 70. See how this almost stops? And then I'm going to go ahead and kick this over. To the 89 degree mark. 89 directional, 0 on, well, if we're a pilot we call it glide slope. But anyway, it's a planular azimuth. That's the direction our nose is pointing. This is the direction our craft is traveling. You can see that we're climbing up to, so I'm going to back off get my speed to where it starts to just stop but move forward. Right there. So it's starting to move forward pretty fast. We're very far from 30 seconds, so I'm going to back it off. I might lose a little, but you'll watch this. Oh, nope, it's moving in a positive direction. So I'm pleased with this. This is settled into a 90 degree, which is near perfect for our moon. So now I'm watching seconds to apogee, altitude of apogee, actual altitude and vertical speed. I can also see this tells me a little bit about vertical speed. So as I get closer, and when we get to about the 30-second mark, I'm going to slow this number down. And I do that by giving it gas. And I may not be slowing this number down. There it goes. But I'm speeding this number up. And the closer we get to 2250 with this number, then the slower this number will get to go. It might even start to move backwards at some point. I'm going to make an adjustment off the 90. 18, 17, 1690. Alright, slowing way down. Like almost to here. 14, 13. It was kind of hard to control without full gas. So let me get this back under control. I'm at 19.5, 4 seconds to go. 2 seconds to go. 1 second. Okay, so at this point I just go for 2250 or 22 and then look. 22 on my mark. Alright, so we're at 54,000 and we're 47 seconds too. Let's go look at that. It's a non-concentric orbit. And when we close up to this, then we can just make a micro adjustment. And we have 26 seconds to go, so while we're doing that, I'm just going to set the target on the moon. We needed to set that target. 16 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, fire. Alright, so we're going to put it on 95. Now you see we're 3 degrees off on our ascending platular comparison. Would that be called platitude? Where our planes have the same altitude or latitude? Platitude? I don't know. Anyway, it's basically the tilt against the 90 degrees against the tilt of your planet. And it's interesting because the moon and the earth have the same tilt, so when we set the moon as a target, then we can see that we are 3 degrees off right now where we're at. And you can actually see it right here, how we're not on the exact place we need to be. So, as we come to our ascending node, we need to point our craft straight up. And I'll show you how to read that on the ball, too. See these? Triangle with the little extra target on it. That's ascending, and if the target reticles are not there, then that's the descending. And I know this is the ascending node because there's a plus sign in front of that 0.03. So what we do is we come right up here on it. Accelerated time. And as we get close to it, and let me show you which way we're pointing, by the way. Where's my craft? Oh, there it is. Okay, so I'm pointed directly north with the craft. And as we approach it, we just give it a little gas and make it a 0. And we just made an adjustment. Now I like to sometimes line mine up like that. That was a full adjustment. And then we're going to go back to what we call our prograde node, which means positive or plus. We're going to make the circle bigger at the appropriate moment. I don't know how much gas I have. And how this works is, I wonder if we can draw, add maneuver. So this is the first time we can actually plan our maneuver. And you can do this for efficiency. You can see the moon intersection, hit the apoapsis right there. And now we're passing it by. So I could actually adjust that to a more efficient state. Which means the 1-0 mark right there. And then we change that into about a 50. .32 is fine. That's an 18-second burn in 4 minutes and 55 seconds. So that's pretty amazing. Now, the other thing that's amazing is we're in near Earth, or near Kerbal orbit, so we're going to get 25 science points. And I'm going to EVA, collect. I'm going to restore. Board. Now the one thing we can do is accelerate, warp to the next maneuver. And that's going to put us about a minute from. Now that we've drawn our maneuver, this little thing here, this is a projected adjustment. And what that means is if I want to and I put my dot right on there, I can start now. I can start ahead of the game. So I'm just going to start with a little gas, just a little bit. As long as I'm on that blue dot, I'm good. And then this is going towards the positivity, towards the goal. And you can see we're actually, as we go around the planet, the object moves with us. Now when I'm in the middle of here, this is my mark. And if you notice, the moon's not up yet. So the way we were doing it before is not as efficient as projecting its arrival and then burning past. And then you just kind of go full speed like this if you want to. No, let's don't. Let's bring it down to appropriate G-force and draw this down. We're going to 25, 24, 23, 22. And then I can make a little finite adjustment this way. 6, 5, 4, 3, 2. On my mark. Okay, we just ran out of gas. Let's see what we have. I'm going to shut this off. I'm going to turn off the projection. And we are actually, I think, on a collision course. I'm going to spin this around. I'm going to point it right. No resistance. I'm going to put it right in the direction. I'm going to release it. And then we're going to ride to the moon together. Now I know I'm going to have to make an adjustment. I believe I saw myself on a collision course. So One thing I want to do is turn on my communications array. I'll just leave that open and on. It's going to burn a little bit of... But look where we're at. We've got a whole tank of gas. I'd actually like to have a little more gas than that, but so there goes the object. We're not in radio control yet, so I can't actually shut my computer off, believe it or not. And if I go up here and look at my actual projection, or what I actually am, I believe I hit the 32. And you can see, if we mess up real bad, we'll get tossed right out into a solar orbit, which that's where I'm hoping our space debris goes. That's what we did with an Apollo. We just sent it out into a solar orbit. Alright, so I'm going to come to here. I can't click on the line. I'm going to speed up the time. Let's just get our signal back. Turn this off. Turn this off. And I'm worried that if we fly all the way in a solar eclipse, we will lose our power. And that can happen if the sun, it just goes behind the moon as we travel. It could be a problem. Okay, the sun is not a problem. It's the radio that's the problem now. Here's the object we released. Let's see if we can see it on the map. So we can see the varying projections of our debris versus us. And I'll tell you the truth, I think I'm on a collision course with the moon. We may have to make an adjustment when we get there. It's easier to make the adjustment now, but okay. I'm going to speed it up until I become about the halfway point. Right about there. I'll do me a material bay. 37.5. I'll keep that. Radio's still dead. So let's just go ahead and speed it up. Alright, so we've got radio contact now. Let's shut that thing off. And it looks like I'm going to hit the moon. So, what you basically need to do, go between this one and that one, somewhere in here, do a test, see what happens. Okay, that's opposite. So go to the opposite of that at about here. And just try to give yourself a periapsis. Alright, 27,000, that's good. Alright, so let's go ahead and speed up time. And of course, this is going to change now. And you can see that our space junk is on a collision course. And we are going to come in at 27 with, looks like a full tank of gas. We're going to see if we can't visually see the collision. Did you see it? I sure didn't. Anyway, let's just go on into my periapsis. We can see 12 minutes to, let 10 minutes to, 9, 8, 7, 6, 5, 4, 3, 2, 1. Wow, 30 seconds to periapsis. "25 minutes. So we'll monitor the gas. The good thing is the Terrier engine works great in a vacuum, and the Moon's a vacuum, so we get some really good fuel efficiency here. And if I pull those till they're opposite like that, I'll have 24, 32. Drop that down to about 9. Alright. And then we'll go over to the 88 and drop this down to 88, and then we'll go home. One thing I can do is an EVA. So we are above the Moon's Midlands. Let me see if this does any good. 75. Near the Moon. Keep. EVA. Collect data. Remove data. Restore. Board. Alright, now I'm not going to get so caught up in the material bay that I instantly forget my goo. Keep experiment. Pressure data. Keep. And my temperature. Keep. All that's good science. And I have a whole nother side to do. I've already done with these near Earth orbit, far Moon, near far Earth, or Kerbal. So let me not forget my crew report. And I can review my report and transmit. So there's Eve. That's one of our destinations. Moho, Duna. So here's 3 planets right here: Eve, Duna, and Moho. They just look like stars in the sky, but they're actually planets.